All right, good morning, and we're going to talk about rational exponents, or I'm sorry, good afternoon, good evening, whatever it may be for you. But we're going to talk about rational exponents, and we want to be able to evaluate numerical expressions using the properties of rational exponents. And then we want to simplify algebraic expressions using the properties of those rational exponents. Now, using the numeric ones is going to be great for some of you because we're just going to plug that into the calculator. It's going to give you the answer. But being able to understand the exponents and how they work will allow you to be able to do the ones that are algebraic expressions. So looking at first when we begin, let's look at this power. And we have a power, and we know that if we have the radical and I have some value here, goodness, 4. How about the square root of 4, right? The radical, square root of 4. And this would be my radical. And this would be my radicand. What I'm trying to find the root of. And this is referred to as a square root because one thing that we don't really identify is just sort of an accepted or known that it is the square root. And this is called my index. And what that means is I am looking for a number when I multiply it times itself will give me, that was not a highlighter. So I'm looking for, in this case, if I rewrite this, I'm looking for the square root of 4, which is also 2 times 2. So I was able to find that number, right? We always say, hey, the square root of 4 is 2. Why is it 2? It's because we were looking for a number that we multiply times itself twice, right? Once, twice, once, twice, and then that would be, therefore, the square root of 2, or square root of 4 is actually just 2. Now, in the big scheme of things, what does that mean? We have any value we want. Any value we want. We'll call it A, and we'll call my index N. And if you think about it, what is the power of A? What is the exponent of A right now? Well, the exponent of A right here is the same thing as the exponent of 4 right here. That was 4 to the first power, and A is to the first power. So this is where we start looking at a rational exponent. Well, a rational exponent is simply going to look like, that is going to turn around, and that is going to be A to the first over N. Now N, again, was my index. That was the root I was looking for. The index, and then the 1 is going to be the exponent of my base. Well, I guess we forgot to talk about base too, right? The base, that is my base value. This is my base of, I'm sorry, it's not, take that back. That is my radicand. This is going to be my base when I talk about a exponent and a power. So in order to convert from this rational exponent, I simply make the denominator is going to become my index, and the numerator is going to be the exponent of my base, or my radicand. So listen, it's going to just do a little bit of conversions here, but it's not going to be too difficult for us. So as we do that conversion back and forth from a radical to a rational exponent, if we look at this first example here, I've already talked about this, the square root of 4. Well, the square root of 4 is understood 2 is my index, and then 4 is to the first power. So I will have 4 is going to be my new base. 1 is going to be the numerator of my exponent, and then the index is going to become the denominator of my exponent. So that is moving from radical to exponent. Now, if I want to go from this rational exponent right here in this next example, right? So I have a base here, 8. That becomes my new radical, my new radicand, sorry. So my radicand is 8. My numerator is going to be the power of my radicand, and then the denominator is going to become my index. So there you have it. I have the cubed root of 8 to the first power, or the cubed root of 8. And the same thing here. 8 is going to continue to be my base, right, in this next example. And then it is going to be 8 to the second power, and then it's also still looking for the cubed root because my denominator is 3, so that would be the cubed root of 8 to the second power. Goodness, let's see here. So it looks like this is going to be my base of 16 is going to be my radicand. The 4 is going to be my index, right, the denominator, and then of course it is going to be 16 to the first power. And I will tell you that all of these, you can plug all of these into the calculator and it's going to give you an answer either way that you plug it into the calculator. But this one, however, we want to let's just go ahead and see if we rewrite that. Remember, my radicand is going to become my new base, and then my index is going to become my denominator, and then my power of my radicand is going to become my numerator. So that is converting back and forth. And now, looking at just doing that conversion, what we're going to do, we'll show the exponent rules. We've got to remember the exponent rules still apply here. So remember that as we look at our exponent rules, we want to remember some of the things that we've learned already, that any number to a negative exponent is going to be the same as 1 over that number to the positive exponent. When we are multiplying like bases, we add the exponents. So a to the m times a to the n, we would have a to the n plus n. And let's see here. So this would be, if I threw some examples in here, we would have, let's see here, x to the negative first would be the same thing as 1 over x to the first. If I had x to the second times x to the third, that would be the same thing as x to the fifth, because I added my exponents. Now we're looking here at, if I have ab, this product raised to a power, that power goes to both of the items within the parentheses. That's why it would be a to the m power, b to the m power. Or if I had the example, would be xy to the third. That is the same thing as x to the third, y to the third. And here I have power raised to a power. So I have a to a power raised to another power. Well, that is going to be multiplication. So if I have y to the second raised to the x power, that is the same thing as y to the 2x. And I know that I used a variable there, but it's still multiplication, right? That's still multiplication. Then when I have division of like bases, I would subtract the exponents. So I would have possibly, let's see here, x to the fourth over x to the first is going to give me x to the third, because it would be 4 minus 1. And then finally, this last example down here, remember in our exponent rules, is that the m is going to be to both the numerator and denominator. So that's why we have a to the m over b to the m. So if I had x over y raised to the third power, that would be x to the third over y to the third. So just using some exponent rules to remember that they're going to be applicable when we talk about the properties of rational exponents. Okay, so converting these into our properties of exponent or rational exponents, if I have 4 to the negative 1/2, that is going to be the same thing as 1 over 4 to the 1/2, which turns out to be 1 over 2, because I'm looking for the square root of 4, which is 2. Now I have two like bases here. I have multiplying 2 to the 1/2 times 2 to the 1/4, and again, we can put this into the calculator, but if you don't understand the properties, when it starts getting into algebraic expressions, you're going to have some difficulty. So that would be 2 times 1/2 plus 1/4, which, remember, when you're adding fractions, you need to have common denominators. So that's going to end up being 2 to the 3/4. When I'm looking at the product here in this example, I have 4 times 9 to the 1/2, which would be 4 to the 1/2 times 9 to the 1/2, which turns out to be 2 times 3, which is 6. Let's see what else. Power raised to a power here is going to be multiplication, so I'm going to have 2 to the 1/2 times 1/3, which is going to give me 2 to the 1/6. And let's see, we have like bases in division. So I'm going to have 2 to the 0.75 minus 0.5 is going to give me 2 to the 0.25, also known as 2 to the 1/4. And let's see here, this last one, I'm going to have this fraction raised to a power, so that means I'm going to have 2 to the 1/2 over 3 to the 1/2. Now, they didn't ask me to, but could I convert those into a radical form? Well, hopefully you can. So, again, what we just learned in the radicals, I'm just going to plug them in here real quick, but think about it before you go forward. And there you go, I plugged in the answers real quick, but again, some of those you would have found in a calculator, and some of them you would have had to just know the properties. As we work with a couple of algebraic examples, if I take this expression, xy to the 2/9, and I'm looking for an equivalent, we can write this in many different ways, but one thing I need to remember here is that is going to be the same thing as x to the first times y to the 2/9. And if I wanted to write that in a radical, that would be x times y raised to the second power for the 9th root. So remembering that conversion as I go back and forth between my radical and my rational exponent, I need to be able to do that conversion and recognize it. Let's see here. Remember, this is multiplication. So I could even write that as x times the 9th root of y to the second power. Again, all of these things are the same, but we do need to be able to recognize these expressions. Let's see here. Another example might be if we were looking at the cubed root of x to the 5th power y. Well, what would be an equivalent expression there? Well, I do know, again, this index. The index becomes the denominator of the power. So if I were to, again, I'm going to separate this a little bit. So I have the 3rd power of x to the 5th times y to the 1st. You got to remember, wasn't an exponent there, but we know it's 1. So as I do that conversion, right, this becomes my denominator. So that equals x to the 5/3 times y to the 1/3. And, I could even simplify that more, that I could say, well, heck, it could also be simplified as, this might be x times x to the 2/3 y to the 1/3, because I was able to find one of the radicals in there. But anyway, there's just multiple ways to write that, and making sure that we are able to move back and forth between the forms, because it is recognizable in that sense. And then I guess I'll give one last simplified form here. And if we have maybe 256 x to the 16th raised to the 1/4, well, that is going to be equivalent to, remember, right, this exponent goes to both, power raised to a power, so that is going to be 256 to the 1st times 1/4 times x to the 16th times 1/4, which is going to be 256 to the 1/4 times x to the 4th. And then when I plug 256 into the 1/4, well, that's going to turn out to be 4. 4 times x to the 4th, or 4x to the 4th. So there you go. There's some examples working with these rational exponents, and we want to be able to evaluate those numerical exponents and algebraic expressions, numeric expressions, algebraic expressions using those properties. And yes, exponents can be fractions, and to convert between exponential and radical form, use the relationships. The numerator becomes the power of the base, and the denominator becomes the index of the radical.